Today, let us look at a cone. A cone is formed by rotating a right triangle along one of its shorter sides. Let us see how. Similar to a cylinder, a cone also has radius of the base and height. But there is another dimension which is called the slant height. If you look at the right triangle, then the radius and height form the shorter sides of the right triangle, whereas the slant height forms the hypotenuse of the right triangle. Let us represent these dimensions as small r, small h and small l. Now the volume of a cone is 1/3 of the volume of a cylinder with the same dimensions, or it is 1/3 times pi r square h. Let us cut and open a hollow cone along the dotted line. We can see that it forms a sector of a circle with radius L. Small l is the slant height of the cone. Now, if I were to cut this sector into small right triangles, let us say a small right triangle with base B1 and height L, then this triangle would have an area of 1/2 times B1 times L. Recall that area of a triangle is half times base times height. Now let us add another such triangle with base B2, and let us start adding all areas of such triangles. So half B1L plus half B2L. Similarly, half B3L. And so on. And so on. And so on. Now let us take half times L common. In the bracket, we get B1 plus B2 plus B3 and so on till we add the bases of all such triangles. Or the bases of these triangles actually form the arc of this sector. So we get half times L times length of this arc. Recall that the length of this arc is actually perimeter of the base of the cone. So we can write the perimeter of that base as 2 pi r. Upon simplification, we find that areas of all such triangles add up to pi r L. Hence, lateral surface area of this cone is pi r L. What about the total surface area? That would be the lateral surface area plus base area, or pi r L plus pi r square. We can take pi r common, so it would be pi r times L plus r. Let us look at a problem. A 12-meter deep conical pit is dug in the ground. If it has a top diameter measuring 2.1 meters, how much soil has to be dug out? It has a base with diameter 2.1 meters and a height of 12 meters. Now we want to find out the soil that has to be dug out. This would form the volume of soil or the volume of cone. We know the formula is 1/3 times pi r square h. Let us substitute the values and simplify. And calculate. So the volume of soil that has to be dug out comes out as 13.86 cubic meters. Let us look at another problem. A birthday cap is in the form of a right circular cone. Ayush wants to make personalized caps for 5 friends on his birthday. If each cap has a base radius of 7 cm and a height of 24 cm, how much sheet of paper does he need to buy? Now we are given this cap has a radius of 7 cm and a height of 24 cm. So the sheet of paper required would actually be the curved surface area of this cone, or pi r L. Let us look at the right triangle that forms this cone. We know the radius and height. How about L? We can apply the Pythagoras theorem as L square is equal to R square plus 8 square, or 7 square plus 24 square, which is 49 plus 576. Wait, is there a way to make the calculation of 24 square easier? We could write 24 as 25 minus 1. Let us square both sides. Does this remind you of an algebraic identity? Yes, a minus b whole square. Let us expand. A square minus 2ab plus b square. It gives us 625 minus 50 plus 1. Minus 50 plus 1 results in minus 49. Wow, 7 square results in 49. We can actually subtract that. This makes it easier. We can write 24 square as 625 minus 49. So we get L square as 625, which is 25 square. So L is equal to 25 centimeters. Now let us substitute the values and simplify. We get the curved surface area of one cap as 550 square centimeters. So the sheet of paper required for 5 friends would be 5 times the curved surface area of one cap, or 5 times 550, which is 2750 square centimeters. But this problem is not complete. This is the minimum sheet of paper that is required for making these 5 caps. When Ayush will make these 5 caps, he will definitely waste some of the paper in pasting, in cutting. So the sheet of paper required would be much more than what we have found out. Let us look at another problem. A heap of wheat is to be covered by canvas to protect it from rain. Find the area of the canvas required if the heap is in the form of a cone whose base diameter is 10.5 meters and volume is 346.5 cubic meters. So we have a heap of wheat in the form of a cone. Now this has to be covered by canvas. And we are given the base diameter as 10.5 meters. We can write diameter as 2 times r. But we are not given the height, nor are we given the slant height. However, we are given the volume as 346.5 cubic meters. So 1/3 of pi r square h is equal to 346.5. Let us substitute the values and simplify. Let's cross multiply and simplify again. Let us remove the decimals. Since there is one decimal in the numerator, we get a 10 in the denominator while replacing it. And since there are 2 decimals in the denominator, we get 2 tens or 100 in the numerator while we replace the decimals. Let us simplify again. So we get height as 12 meters. Alright, now we know the radius and the height. But for curved surface area, I need pi r L. I also need to find out the slant height. Let us apply Pythagoras theorem again. The calculation here is a little complicated, and to find out the square root, we actually need to follow the long division method. Small l is equal to 13.1 meters. Let us substitute the values and simplify. We get the curved surface area of the canvas as 216.15 square meters. Let us recap the volume and surface area of a cone. In the next lesson, we shall look at the surface area and volume of a sphere.